Continuing with the similarity of triangles, here he is saying that in triangle PQR, MN is parallel to QR and PM upon QM is 2:3. We have to find MN upon QR and we have to prove triangle OMN and ORQ as similar. Okay, and after that we have to find the area of triangle OMN is to area of triangle ORQ. Okay, that means we need to prove them similar before finding their areas. Fine. So let's proceed. First we will take triangle, because we have to find MN by QR. So we will take triangle PMN and PQR and prove them similar. So in triangles PMN and PQR, angle P is common in both. Angle P is equal to angle P, common. And angle PMN is equal to angle PQR by corresponding angles. PMN is equal to angle PQR, corresponding angles, because MN is parallel to QR. Fine. Therefore, triangle PMN is similar to triangle PQR by AA axiom. Fine. Now, you can write area of triangle PMN upon area of triangle PQR is equal to PM square upon PQ square, right? PM and PQ. PM is given 2 and QM is given 3. So this can be written as 2 upon PQ becomes 5 then. So this becomes 2 square by 5 square. So you got area of triangle PMN upon area of triangle PQR as 4 by 25. Right? Now, if we set the proportionality here, what will we get? We will get PM upon PQ is equal to MN upon QR is equal to PN upon PR. Right? We have, this was by theorem. Right? We have to find MN upon QR, which is equal to PM upon PQ, right? So PM upon PQ is 2 upon 5. So PM square upon PQ square is 4 upon 25. But we will directly use this equal to this. So you can write MN by QR is equal to 2 by 5. This is done, right? Okay. So then you have to prove that OMN and ORQ are similar. Okay. So how will we prove them similar? This angle is equal to this angle. So you will write in triangles OMN and ORQ, angle MON is equal to angle ROQ. Reason, vertically opposite angles. Another is angle OMN is equal to angle ORQ. Alternate angles. Therefore, triangle OMN is similar to triangle ORQ. Right? So this part you have proved by AA axiom. Now you have to find area of triangle OMN. Now if they are similar triangles, therefore area of OMN upon area of ORQ is equal to OM by OR, right? OM by OR, OM square by OR square, MN square by RQ square, MN square by RQ square, ON square by OQ square, ON square by OQ square. But out of that you have already calculated this as 2 by 5, right? So you will directly use the value of 2 by 5 here. So you will write now, therefore area of triangle OMN upon area of triangle ORQ is equal to MN square by RQ square, which is equal to 4 by 25, right? So what is the ratio? Ratio is 4:25. That's what you had to find here.